The image you're seeing once spread like wildfire across the internet. It showed a disturbing pink foamy paste, rumored to be the raw mixture behind McDonald's chicken McNuggets. For millions of people, the idea was shocking. Was this really what we'd been eating all these years? The picture ignited fear, headlines, and endless debates across dinner tables. McDonald's had no choice but to address it directly. In a bold move, they even used a Super Bowl commercial to confront the rumor head-on. The question was simple: what's really inside McNuggets? Is there any truth to the pink goop theory? McDonald's firmly denied the claims, insisting their nuggets were made from white meat chicken, not some strange foamy substance. But denial alone wasn't enough. The image had already etched itself into public memory. So what's the truth? To find out, we step inside the McDonald's processing plant and follow the journey from raw chicken to that crispy bite you dip into barbecue sauce. Chicken McNuggets first hit menus in 1983. The idea was genius, a handheld snackable item customers could enjoy quickly, with or without fries. The product was an instant success, spreading nationwide within just a year. Backed by family-friendly ads, nuggets became a global phenomenon. Despite health debates, viral rumors, and changing consumer tastes, they survived and even thrived. From New York to Tokyo, the McNugget was here to stay. Every nugget begins with truckloads of raw chicken delivered to the processing plant. Quality and safety checks happen immediately. Inspectors verify temperature, color, and freshness to ensure no compromises. The cuts include mostly white breast meat, blended with smaller amounts of skin and fat for texture. These parts are ground together into a fine base. Massive stainless steel grinders, machines the size of cars, reduce hundreds of pounds of chicken per minute. The ground mixture flows into industrial mixers, spinning like oversized dough machines. Precision is critical. Every batch must contain the exact same ratio of meat, fat, and seasoning. Even a slight imbalance could ruin the familiar bite McDonald's has standardized worldwide. The chicken blend is then pumped into molding machines that stamp out nuggets in 4 iconic shapes: the bell, the bow tie, the ball, and the boot. These shapes weren't chosen randomly. They were designed for even cooking and a playful appeal for kids. Which shape do you grab first? The boot, the ball, the bell, or the bow tie? Freshly molded nuggets tumble onto conveyors where they receive their first thin coat of batter. This initial layer acts like glue for the next stage. Nuggets are then rolled in seasoned breading inside rotating drums, where flour dust fills the air as every surface gets coated. This is where that signature golden crunch begins. Next, nuggets drop into hot oil vats for a precise 35-second par fry at around 175 degrees Celsius. The goal isn't to cook them fully, just to set the breading and create a golden shell. Steam rises, the aroma of fried batter fills the plant, and thousands of nuggets emerge looking nearly finished but still raw inside. From there they speed into blast freezers set at -40 degrees Celsius. In just minutes the core temperature drops enough to lock in freshness for transport. Automated arms swiftly load the frozen nuggets into sealed bags and cartons, stamping each with batch codes and dates for traceability. Any imperfectly sealed package is rejected on the spot. Finally, pallets stacked with frozen nuggets are shipped worldwide. Once they arrive at McDonald's restaurants, workers give them a second deep fry, this time cooking them fully to crispy golden perfection before they land in your box. From farm to fryer, the process takes weeks, but from box to bite, it takes just seconds. A single McNugget may look simple, but behind it lies a story of science, precision, controversy, and mass production. In 1985, something extraordinary happened at Dairy Queen. Crowds of Americans lined up outside their stores, eager to try a dessert so thick and so daring, it could be flipped upside down without spilling a drop. That summer, the blizzard wasn't just introduced, it became a nationwide phenomenon. More than 175 million cups were sold in the very first year, a number that stunned the fast food industry and cemented the blizzard as more than a treat. It was a cultural event. The moment a server flipped the blizzard upside down before handing it over became iconic. It wasn't just dessert anymore, it was a dare, a ritual that dared gravity itself. But how could soft serve stay smooth, creamy, and perfectly blended with cookies and candy while still defying gravity? To uncover the secret, we step behind the counter and into the mixing rooms where blizzards are engineered with scientific precision. Although the blizzard officially launched in 1985, the idea of blending toppings into soft serve wasn't new. Small shops had experimented with the concept before. What set Dairy Queen apart was scale. With hundreds of locations across the United States, their blizzard could reach millions almost instantly. Its first year alone was nothing short of historic. 175 million sold, almost one for every American alive at the time. The upside-down flip quickly evolved into a marketing masterstroke. Customers didn't just see ice cream, they saw proof that this dessert was different, sturdier, and somehow more indulgent. Behind the scenes though, keeping soft serve dense enough to hold toppings, yet creamy enough to enjoy, required a level of engineering far beyond what any home blender could manage. Before the soft serve even touches a cup, Dairy Queen has already perfected the cone. It begins as a simple batter of flour, sugar, and water, mixed to a silky liquid, and then poured into cone-shaped molds. Inside high-heat presses, the batter bakes in seconds. Pressure creates the ridged pattern and satisfying crunch we all know. Once baked, the cones ride a cooling belt where circulating air hardens their structure. Any cone that cracks or warps is immediately discarded. Only flawless cones pass inspection. From there, workers stack them into tall sleeves and seal them airtight to lock in that crispness until the moment they meet soft serve. Now the real star, the ice cream mix itself. Dairy Queen's proprietary blend of milk, cream, sugar, and stabilizers is shipped across the country in refrigerated tank trucks. When it arrives at each store, the mix is pumped into chilled hoppers set to around -8°C. Constant churning freezes the liquid while whipping in just the right amount of air, about 40% overrun. This is what gives the blizzard its signature light, yet indulgent texture. Workers carefully monitor butterfat levels and temperature to ensure that a blizzard in Texas tastes exactly the same as one in Minnesota. Then comes the magic moment. Into the soft serve go Oreos, Reese's, M&M's, cookie dough, or seasonal favorites. The filled cup is locked under the blizzard mixer, a specialized machine that blends candy into ice cream in roughly 7 seconds, just enough time to distribute toppings evenly without melting the mix. Each spin is measured, every scoop designed so that no matter where your spoon lands, indulgence is guaranteed. And then the flip. Before it reaches your hand, every blizzard is turned upside down. It's more than a gimmick. It's proof of stability, density, and Dairy Queen's commitment to a dessert that doesn't just taste good, but performs. If you've ever tested your own blizzard with that daring upside-down flip, you're part of a tradition that's been thrilling customers for nearly 4 decades. But ice cream isn't the only indulgence with a story. While Dairy Queen defied gravity, instant coffee has come a long way since it first made its debut in 1890. From fueling early morning commutes to keeping students awake during late-night study sessions, it's become a trusted companion for millions. At the forefront of this global caffeine culture stands Nestlé's Nescafé, a brand brewing an astonishing 1 billion cups every single day. But behind every sip, they're placed into ceramic-lined fermentation tanks filled with clean mountain water. Over the next 12 to 24 hours, the mucilage breaks down naturally. Farmers monitor this step with precision, too short or too long, and the flavor could be ruined. Once softened, the beans are tested by hand, then fully submerged again, and stirred vigorously with wooden paddles to scrub them clean. Dirty water is drained and replaced until the beans are spotless. With their parchment layer intact, the beans are now ready for sun drying. Spread evenly across large drying surfaces or raised beds, they bask in the warmth for 1 to 2 weeks. Farmers turn them regularly to ensure even dry coffee beans arrive at the Nestlé factory. These aren't just lifted off by hand. This is the age of robotics. A powerful robotic arm, equipped with a spider-like gripper, swiftly unloads the heavy sacks from trailers, protecting workers from back injuries. Once on an extendable conveyor belt, additional robotic arms push each bag into position with precise movements. Before the beans even get close to roasting, they pass over a moisture sensor. This high-tech device checks the humidity inside each bag. If a bag floors shake off debris, stones, or any foreign particles, it also separates out smaller or broken beans. Only the highest quality is allowed to move forward. But before these beans face the roaster, they meet the most critical inspectors, human tasters. These experts sample up to 100 cups of coffee daily, detecting the tiniest variations in flavor. In coffee production, even a single flawed bean can spoil the taste, so their role is vital. Once approved, the beans enter an industrial double-walled rotating drum, roasting at temperatures between 375 and 545. Paddles keep them in constant motion, ensuring even roasting without burning. Depending on the desired flavor profile, roasting lasts between 8 and 20 minutes. Lighter roasts retain more caffeine, while darker roasts offer bold flavors but slightly less caffeine. When the roasting ends, the beans are rapidly cooled with fans in a swirling cooling tray for 5 to 10 minutes to lock in the aroma. Next comes grinding. The roasted beans are fed into massive coffee mills, transforming them into a coarse powder. This powder is brewed under steam and pressure into a concentrated liquid coffee extract, ready for one of two drying methods: spray drying or freeze drying. For Nescafé Original, spray drying turns the extract into a fine mist inside a huge spray dryer. Here, scorching hot air at 1000 Fef blasts through at 400 miles far, instantly evaporating moisture and leaving behind tiny granules of instant coffee. For Nescafé Gold, the process is more intricate. The extract is thickened into a toffee-like concentrate before being sent through a 30-meter freezing hall at -58 Fef. This transforms it into a coffee ice sheet, which rotating blades break into granules. These frozen granules then undergo sublimation, a low-pressure 140 Fef process lasting 5 hours, where the ice turns directly to vapor, preserving aroma and flavor. Once dried, the granules are perfectly shelf-stable. They're packed into large sacks, then swiftly funneled into jars on a conveyor belt, each filled in less than a second. Some factories can fill up to 320 jars per minute, totaling over 250,000 jars a day. The jars are sealed airtight, capped, labeled, and prepared for shipment to coffee lovers worldwide. From a humble green bean to the rich aroma in your cup, every step is a precise blend of science, skill, and passion. It's a process designed to deliver perfection, one sip at a time.